Let's delve into a comprehensive case study and let's try to understand and use our knowledge, as I said earlier, which we've gained in the DMVPN modules to identify and resolve issues. So this is the network topology that we are using for our case study. It is a dual DMVPN hub, dual DMVPN cloud network. We have two hubs, hub 1 and hub 2, and two spokes in the bottom, spoke 1 and spoke 2. And these spokes are connected to both the hubs. And we do have encryption turned on in this network, and we are using PKI or certificate-based authentication for encryption versus using the pre-shared key. I would highly recommend for you folks to actually stop when you come to the problem, to the slide where I'm describing the problem, and think of all of the options which were available, which we actually went through in the previous module, and then try to see which one of those, commands, the show or the debug commands that you can actually use to troubleshoot these problems. This would kind of make this case study more interesting. Problem 1. So users behind some spokes can't reach any network other than, their own local area networking, and connectivity to the data center behind the DMVPN hub is not working. So remember, let's think about the different modules that we actually studied. So what is the first module that we would actually look at to make sure everything is working as far as that particular module is concerned? It would be the physical layer. And in this particular case, we've you can assume that we've actually checked the physical layer, and we do have end-to-end connectivity between the hubs and the spokes. So moving on, the next module, the components, the next set of components that we would need to check at is encryption. So we would start off with looking at the IKE assay in both the spoke and the hub. So in these outputs, you would be using the show crypto IKE v2 assay. What is interesting and what you need to make sure that you look at in these outputs is the local and the remote peers correspond to the hub and the spoke. This is very important. And then you need to make sure that the status actually says ready in both the spoke and in the hub setup. So in this particular case, we do see this status is ready, and the local and the remote peers are pointing to the IP addresses, the NBMA addresses of the hub and spoke. So yes, our IKE assay is up. We can move on. So the next component of encryption that we need to look at is the IPsec assays. In this particular case, we would use the command show crypto IPsec assay. We need to make sure that the IPsec assays are both the inbound and the outbound ESP assays are actually up on the spoke and the hub. So in this particular case, when we look at these commands, we do see, the IPsec assays also up, which is awesome. So we know that our encryption layer looks good too at this point. So we move on to the next module, which is the GRE and the NHRP module. In this case, we do know that the tunnel interface is actually up because the tunnel protocol says up and up. So we would look at the NHRP mappings. So in this particular case, we would use the show IP NHRP next hop server detail or the NHS detail. What is very interesting is that this particular tunnel on the spoke, this mapping on the spoke 1 is actually not getting any responses. So you see the state it is in, it says is E, which means it is expecting replies and it's not getting any kind of replies. And we do see that the requests are failed and the replies received is actually 0. So it looks like an next hop server problem. So let's take a look at the hub one and try to see, what the NHRP database has, the mappings which it has for the specific spoke. So when we go ahead and we can use the command show IP NHRP with either the tunnel or the NBMA address of the spoke, we don't see any mapping. So what happened to the mapping? Because as far as the information that we see on the spoke, we are seeing registration requests being sent. So what we want to do at this point is we need to figure out where exactly these registration request packets are being lost. Whenever you run into some kind of an issue like this, it's always a good idea to go back to the ESP, the IPsec essays, and make sure that we are seeing the packets encrypted and the packets decrypted, that particular counter's value is actually going up. In this particular case, when we run this command on spoke 1, what we are seeing is we are seeing packet encaps, but we are not seeing packet decaps at all. So basically, it looks like we are the spoke 1 is encrypting the packets and sending it across to the hub, but we're not getting the spoke is not getting any responses from the hub. So if we go back and if we look at the hub 1, which says show crypto IPsec essay on the hub 1, what is very interesting is we are seeing these 6 packets. So the registration packets which are being sent from the spoke is actually, it's received on the hub and it decrypts it. But for some reason, it's not sending out the registration replies, and hence the packets encaps or encrypted is that particular counter's value is actually 0. So where are the ESP packets missing, or why is the hub not, encrypting these packets or sending out registration replies? So based on these output, it definitely, the problem seems to be with NHRP. So we would definitely have to go deeper into the NHRP and see what is happening at this particular layer. I would highly recommend before you run any, show commands as far as NHRP is concerned on the hub to see if it's sending out registration replies and it's getting registration requests. It's a good idea to actually clear the NHRP counters on this interface so that you get a clean, counters, and you can start seeing it increment as the packets are coming in. So after you do this and you run the show IP NHRP traffic, it's very interesting that we are seeing those 5 registration packets which the spoke is sending. But guess what? Take a look at the registration reply. That is important because we don't have any registration reply packets sent from hub 1. This really looks to be some kind of an NHRP issue on the hub 1. So I think we will have to go to my favorite part of any kind of troubleshooting, which is debugging. So we will have to, turn on the NHRP debugs so that we can figure out why the hub is not actually responding to the registration request which the spoke has sent. So the debugs that you would be running are NHRP debugs, cache error, and when you run all of these debugs, it is one of the things which I want to call out and is really, really critical. I really can't stress enough on on this. Please turn on the conditional debugs, especially when you're turning on debugs on the hub. Do not turn on any debugs unless and until you've defined the condition. It's extremely important because the hub has, if your hub has a lot of tunnels actually, terminate a lot of spokes terminating tunnels, you can overwhelm the hub with debugs and crash it too, which we absolutely do not want to do. So please make sure that you turn on the conditional debugs. And instead of turning on individual NHRP debugs, you can also use the debug DMVPN detail all NHRP. Again, use conditional debugs. That is very, very important. And make sure that after you turn on the debugs, you go ahead and ensure that the conditional debug is turned on using the command show NHRP debug condition. So once you do this, let's take a look at the NHRP debugs, and let's analyze it and see what we are actually seeing. So in this particular case, we do see the registration request coming in via tunnel 0. Okay. And what is very interesting is this registration request, instead of the hub actually replying to it, we see the registration request is being forwarded. Why? Why is it being forwarded? Doesn't make sense. And then, if you go down the debugs, you're seeing it attempting to send packet via destination 10.0.0.253. So why is hub 1 forwarding it to another next hop server? So 10.0.0.253, if you folks remember our topology, is the second hub. So it kind of doesn't make sense. So we want to go back and take a look at the configuration of the tunnel interface to make sure that we have, all of the information in place correctly. So look at this IP NHRP NHS entry. It is actually pointing to the 10.0.0.253 for tunnel 0, and ideally it should have pointed to hub 1, which is 10.0.0.254. Are these spokes, is there some kind of artificial intelligence or magic? No, I'm sure it is a human error. So once we actually went ahead and changed the NHS mapping back to 10.0.0.254, the users could reach all of the networks behind the hub, the data center, and all of it. Yes. So we resolved problem 1. Next day, problem 2. The users behind all spokes are suddenly unable to reach the data center behind the DMVPN hub. So it's not just some spokes. In this particular case, all spokes are suddenly unable to reach the data center. So again, start off with the first module. Make sure that you have the end-to-end connectivity working, and in this particular case, it's working. We are able to ping end-to-end between the hub and the spokes. So next, go to the second module, which is encryption. So remember, we are going to be checking the IKE. So in this particular case, when we look at the show crypto ISA KMP SA on spoke 1, what we see is we see it actually, look at this connection ID. It says key exchange. So the status is key exchange. So the status here should have been, let's think about it. What is the status that we should have seen here? We should have seen the status as, ready or active, basically, in this particular state, in this particular case. And let's take a look at the hub, the IKE in, entry for the hub. Show crypto ISA KMP essay on the hub also has a status of key exchange. There's definitely a problem with IKE. So because it's not just coming up, it seems to be stuck in, the key exchange. So why is IKE failing? You want to make sure that, you figure out why exactly IKE is failing. So normally what the key exchange status indicates is that there seems to be some kind of an issue with the certificates. Okay, because the MM5 or, remember with IKE, it uses 6 packets before it gets into the QM idle state. So in this particular case, it is stuck on the 5th packet where it looks like there's some kind of a problem with certificate or signature payload failure. Basically, it is a certificate issue. So what we would normally do is we would go ahead and turn on the IKE debugs. And in this case, it tells you very clearly that the validation of the certificate chain failed. So basically, the certificate did not get validated. So how do we actually validate certificates? What you can also do is you can go ahead and run the debugs, and when you continue look PKI debugs, which is debug crypto PKI messages, transaction, or PKI validation, you can run all of these debugs. And what you would be seeing, and you need to look at the PKI debugs. In this particular case, it very clearly says that it's not getting, it's checking to see if the certificate is actually valid within the certificate revocation list. And what we see in this debug, it very clearly says it's not getting a response from the CRL server. So it looks like there was some problem with the communication between the spoke and the CRL server. So this is one of the reasons why we are seeing this as such a widespread problem versus a single spoke. We are seeing this on all of the spokes. So what was as we said, that was a problem with the CRL server. So what was the solution as far as this issue is concerned? Yes, we had to go shopping for a new server because the server on which the CRL was being hosted was actually down. Meanwhile, while the PKI team was bringing up this a new server, we had to ensure that all of the spokes communication was up, and we had to ensure that they can actually access the data center behind the DMVPN hub. So one of the workarounds, the temporary workaround which we had used, was the revocation check CRL was actually set to none till the time the CRL server was actually brought up, and then it was set to required. Problem 3. The tunnel keeps flapping constantly and no traffic is actually flowing from spoke to the hub. In this kind of with this kind of problems, it's very important to understand what is really flapping. Is it the tunnel interface which is flapping because of the routing which is flapping, or is it the actual IPsec tunnel which is, flapping. So it's really important we figure this out. In this particular case study, we were using EIGRP as the routing protocol. So if we were to use the show IP EIGRP neighbors and take a look at the neighbors, what is important here is we see the whole the queue count is set to 5,000. So it kind of indicates, there is some kind of an issue with the EIGRP neighbor relationship. And if you go take a look at when we looked at the logs, we see that the neighbor, is actually going up and down. And it says very clearly that the retry limit is exceeded. So this is very clear that, with all of this information, it's very clear that the tunnel is not flapping, but it is the EIGRP process which is actually flapping. So we need to figure out why is the EIGRP flapping, and you need to start from the spoke because it is this specific spoke that we are seeing, where the EIGRP neighbor is flapping. One of the first things that you need to do is start from module 1, physical layer. Ensure that you have end-to-end connectivity. So when you go ahead and ping the NBMA address, guess what? We are getting a success. So it means that we do have end-to-end connectivity. And then if we were to go take a look at the show IP NHRP mapping on the spoke, we do see the static entry which which you would normally see because you configure the static mapping on the tunnel interface on the spoke. Next, when we look at the show IP NHRP NHS, we are seeing responses and we are seeing replies too. So there doesn't seem to be any problem with NHRP also. So what next? We just to summarize, we are not seeing the EIGRP neighborship with the hub on the spoke. NHRP looks okay on the hub and spoke because we are seeing replies being sent, and we are seeing requests being sent and replies from the hub coming through on the spoke. So and we are seeing ping too. So the first module is okay. The second module encryption looks okay. And even within NHRP, it looks kind of okay because we are seeing the NHS configuration okay, and we are seeing registration requests and replies being sent and received. So it's something very specific with EIGRP. So what we need to think here at this point is what within NHRP or within DMVPN is related to EIGRP or any routing protocol. Remember, I said when I was talking about the mandatory commands which are required with NHRP, I said that it was very important that we enable multicast, on both the hub and the spoke. So in this particular case, what we see is the IP NHRP multicast dynamic was actually missing on the hub. I don't see this particular command on the hub. So what this ended up with when the IP NHRP multicast dynamic is missing on the hub, the multicast packets, the EIGRP multicast packets were not being sent to the spoke. So the two-way multicast discovery which needs to happen before the EIGRP neighbors are formed actually failed. So it was as simple as configuring the IP NHRP multicast dynamic command on the tunnel interface. So it's very important if you are running a routing protocol on your DMVPN setup. Make sure that you enable multicast both on NHRP multicast both on the hub and on the spoke. Let's look at our problem 4. It's a Friday. Yes, thank God it's Friday. We are ready to get out of the door. And the phone rings and somebody says, we have EIGRP neighbor relationship bouncing intermittently on some spokes. We just fixed it. We just fixed it on problem 3. So let's take a look and see what is happening. Again, remember, when we have any kind of a flapping or bouncing interface tunnel bouncing or routing protocol neighbor bouncing, it's very, very important that we understand what is flapping or what is bouncing. Is it the routing protocol? Is it EIGRP? Or is it the tunnel interface or the IP, which in turn affects the IPsec tunnel? Which of it is actually flapping? Go take a look at we take a look at the hub syslogs, and it says tunnel 0 is down, and as far as the adjacency is concerned, EIGRP adjacency is going down. And we look at the spoke, we are seeing the same issue. And what is very interesting is both the spoke and the hub see an EIGRP neighbor flap for over 30 seconds. So in this particular case, there is no information about the IPsec tunnel. So it's very important that we do have IKE keep alives or dead peer detection configured. I did say when I was discussing the encryption module that you can go ahead and configure on-demand DPDs or keep alives, or you can configure periodic, and you would be configuring periodic if the spokes are behind or the hub is behind a NAT device. It's also important that you log the crypto session. So once you enable logging of the crypto session, what you would see in the syslogs is you would see a message which says crypto tunnel is down and up. So it looks like the crypto tunnel is flapping. So what are we going to do next? So it definitely looks like it is both the crypto tunnels which is flapping and the EIGRP which is flapping. So in this particular case, it is not an it is not a problem which happens like pretty frequently. This is an intermittent problems, and intermittent problems are really, really difficult to troubleshoot. I'm sure all of you who are actually listening and learning through this session will sometime in your career have experienced these intermittent issues. So in this particular case, what we would do is we can use the embedded event manager or the EEM script. So what the EEM script does is it's going to check periodically. Like in this particular case, every 5 seconds, it's going to send a ping, to check the connectivity of the NBMA addresses of both the hubs and the spokes. Okay. And then what it's going to do is if it actually loses 3 consecutive pings, then it's going to go ahead and trigger this EEM script, wherein it'll actually go ahead and log a message which says that the tunnel SLA probe failed, or public WAN SLA probe failed. So in this way, we get to know what exactly is happening. So what we found basically was when we had issues where the spokes lost connectivity because of the tunnel interface actually flapping, we saw this message on hub 1 which said that the public WAN SLA probe failed. So basically, what this indicated was there was some kind of an connectivity issue between the hub and spoke. This was the reason why the crypto tunnel was failing. So basically, the EIGRP neighbor flapping, which we were seeing, was a result of the underlying, end-to-end connectivity issue. So this is what we discovered with problem 4, and it was pretty simple. Work with your ISP and your networking team and make sure that your layer 3 is more stable and consistent. Okay. Now that we've gone through and resolved all the problems, hopefully this particular network was stable and we did not see any other problems. So the next, we've kind of gone through the a DMVPN overview. We've learned about the different modules and the DMVPN components associated with each of the modules, and we've gone through the comprehensive case study. Now let's take a look at what is the best configuration practice as far as DMVPN is concerned. It's always a good idea to use mode transport on your transform set because it's going to actually save 20 bytes. MTU issues, because you're going to be having a GRE header and an IPsec header, it's always a good idea to go ahead and reduce the MTU. This particular MTU 1400, which we recommend, is based off Ethernet, the 1500 byte Ethernet packet. So it's always a good idea to set the MTU to 1400 and the TCP adjust MSS to 1360. This is for the TCP packets. The reason we actually set this MTU so low is because it's always a good idea to actually it's ideal to not fragment the packets, after encryption. Before encryption. And if for some reason you have to fragment the packet, it's always a good idea to fragment it after encryption, because this way it would kind of help when it is reassembling the packet at the remote end. Very good idea to set the IP NHRP hold time, and the recommended values between 300 and 600. IP NHRP registration no unique is a command which is enabled by default in our later versions of the code. And it's also, if you do have encryption, it's also a good idea to set up the call admission control on the spokes and a hub. The reason you want to set this is because for some reason, if things go down, if your spokes go down and on in your DMVPN network, and if all of them come up suddenly, you don't want the hubs to be overwhelmed, and it is not a good idea to enable GRE tunnel keep alives because they are not supported. So to summarize what we have covered in this session, we started off with a DMVPN overview where we spoke about the different implementations, what DMVPN is, and a little bit of history and the terminology and features which are used with DMVPN. Then we moved on to the different modules and the components configuration, show commands, and troubleshooting commands associated with each of these components within the modules. And we also looked at the common issues within each of these modules. We continued with a comprehensive case study where we made use of the knowledge which we had gained from the DMVPN modules to identify and troubleshoot different issues within a customer network. And we ended with the configuration best practices, which we at Cisco recommend. I wanted to take this opportunity to, thank you all for taking the time to listen to my presentation. I truly appreciate it. And as I said earlier, if you have any questions, please feel free to email them to me, and I will go ahead and answer as soon as possible. Thank you.